Hello guys, so I welcome you all in this episode of Concept Capsule, and as you know we are coming with different topics in this Concept Capsule which are going to be very helpful to you in the GATE examination, in ESC examination, in BARC, ISRO, DRDO, as well as they are very much useful in the interview sessions also. So guys, when you are going to give interview, these capsules are definitely going to help you. Okay, so this is a kind of booster dose for you. So today's episode we are going to discuss the topic as the name of Coriolis Component of Acceleration. So this is from theory of machines, and also you study the same thing in engineering mechanics also. So guys, we are going to start the session now. So when we are talking about Coriolis Component of Acceleration, many students have different kind of misconception about that. So we will see first of all what this is, when it comes, what is its magnitude, what is its direction, and I will be showing you one question on this and also one mechanism where this is present, and we will see how it is acting, on which body it is going to act. Okay, so the situations when it is going to come into the picture. Okay, so we will discuss everything. Let us start the session guys. So we are going to have this Coriolis Component of Acceleration. So those who are watching me for the first time, this is my introduction. I am teaching from more than last 10+ years. And these are my areas of expertise: engineering mechanics, strength of material, theory of machines, production, industrial and machine design. So let us move further guys. So guys, this is the link of my Telegram channel. If you want to have the PDF of the sessions what are going on, and also if you want to have all the notifications of examinations and counselings and all, so you will be getting everything, handwritten notes and PDF of the session, everything on this Telegram channel. So you need to join Mechanical by Dheeraj Sir. You will be getting all these benefit on that session. Okay, so guys, now this is about we are going to have a GATE 2023 in single attempt. Nothing is impossible. This session is there on this Saturday, and we are going to have this session at 10 PM. So be ready for that. If you have any doubt for this GATE 2023, you will be benefited from that. Okay, so guys, now this is one schedule I want to share here. This is the schedule of engineering mechanics. I am going to start a series from 25th of May, and it will be going till 1st of June, where we will be covering trusses as well as friction. So guys, now I am starting the session. The topic is Coriolis Component of Acceleration. So my dear, when we are talking about this topic, Coriolis Component of Acceleration, first thing which comes into the mind of student, whether it is a real acceleration or imaginary acceleration. So the very first question which arises is whether it is real or imaginary component of acceleration. Whether it is real or imaginary component of acceleration. So when we are talking about whether it is real or imaginary component of acceleration, generally students have a misconception that it is a kind of imaginary acceleration. Why they feel like that? Because they have listened to acceleration due to gravity. They have listened to some radial, or you can say centripetal acceleration. They know something about tangential acceleration, but they have listened very less number of times this term, that is Coriolis. So they feel maybe it is imaginary, maybe it is not coming into picture every time. That's why we don't know about that. So my dear, when we are talking about Coriolis component of acceleration, it is a question into the mind of student whether it is real or imaginary. So my dear, I would like to tell you that it is not an imaginary, it is a real acceleration only. So this is real only, but not an imaginary acceleration. Guys, actually there are so many things when we are going to talk about. So our concentration is first of all, let us discuss the things which are present. So it is not like that we will be making something imaginary and then we will discuss. So guys, this is definitely a real acceleration. And my dear, when we are talking about this acceleration, you know, acceleration is a vector quantity. So this acceleration is also having both magnitude and direction. And my dear, when we are talking about the magnitude of this acceleration, it is given as 2v omega. I will be telling you what is v and omega in this, and direction also we will be talking about. So first thing, it is not at all an imaginary acceleration, but it is a real one. But my dear, then why we have seen this acceleration at very less places? Why not like radial, centripetal and other acceleration? We have seen it many times. The reason, my dear, is because this acceleration is acting in some special situation. And what is that special condition or situation when this acceleration is going to work. So that special situation or special condition is, my dear, when one body slides, over another rotating body, So my dear, this is coming in special condition. What is the special condition? When one body is going to slide over another body which is already in rotation. So the point is, when one body is rotating and on that rotating body if some slider is present and that slider is sliding also, then only this acceleration will be coming into picture. And that is a very, you will say that not very rare, but definitely this situation is not very common also. So you will see such kind of situation in some particular mechanisms, like crank and slotted lever mechanism is there, like Whitworth is there. So there are some specific mechanisms only where you will see that one body sliding over some rotating body. So that is why this acceleration is not very common. It is found in some specific situations or conditions only. So my dear, that is the reason why you had a misconception that it is an imaginary acceleration, but it is a real one. So my dear, the magnitude of this acceleration is 2v omega. So now it is time to tell you that what is omega and what is v. You know that it is coming when one body slides over another rotating body. So my dear, this v is nothing but velocity of slider. You can say it is a sliding velocity of slider, and when we are saying the rotating body, it is the angular speed or angular velocity of rotating body. So it is the angular velocity of rotating body. So guys, now I feel you are very much getting this, that what is actually the Coriolis component of acceleration. So this 2 into v into omega, v is the velocity of slider or sliding body, omega is the angular velocity of rotating body. So my dear, now we will see about direction also, but first of all I would be telling you once again whatever we have seen, where it is present. So I am taking this to tell you. So my dear, let us say we are having a situation when we have a rotating body like this, but on this body this slider is not sliding. Then guys, you will be saying Coriolis component of acceleration is 0. We can also have another case when slider is sliding but this body is not rotating, then also Coriolis component will be 0. But my dear, when you will be having this body to be rotating and body slider to be sliding, then Coriolis component will be 2 into v into omega. So my dear, this is how when we are talking about 2v omega is acting. So it will be coming only when rotating body will be rotating and sliding body will be sliding. Otherwise, this component of acceleration will not at all come. Okay. So my dear, now I will show you that yes, if it is real acceleration, there should be some motion generated by this acceleration, because forces, what they do, they just try to make the body which is in motion to be in rest, or if the body is at rest, they try to make it in motion. So what is the work of a force? It is going to change the state of motion. So my dear, acceleration, when I am saying, obviously the presence of acceleration guarantees that force is present. So my dear, when we are talking about this acceleration, what kind of motion this acceleration can cause? So my dear, let us feel, if we have a body where omega is 0, as I already told you, and velocity of sliding is present, this is present, then this slider would be moving in this direction and it will be moving some distance in some time. And if you say the slider velocity is 0 but this is rotating, then slider would be reaching in this position after some time. But my dear, if both are present, then what is going to happen? My dear, only rotation can cause this motion. Only translation can cause this motion. But you know that if this is a slider and the body is rotating with omega and slider is going with v, slider will not be reaching to this position, but slider would be reaching to this position. And my dear, that extra motion, if you are capable of identifying that extra motion, when you are going to identify this extra motion, so my dear, this extra motion is coming due to that Coriolis component of acceleration. Now many of you would be thinking that, sir, this motion is coming with the slider. Yes, because Coriolis component of acceleration is acting on this sliding body, which we have mentioned as 2 into v into omega. So my dear, this Coriolis component of acceleration, what we have discussed is 2v omega, that is acting on the slider, on the sliding body, and that is why this extra motion is coming for the slider. If you will be giving this motion to slider like this, linear, without any link, because omega is 0, and if you will be giving this slider as a rotation like this, because here slider is not sliding, so then slider would be having individual motion, this, and it would be reaching to this place. Even you can show this motion like first translation then rotation, because rotation will remain same, because individually when you will be giving this motion to the slider, that slider is going to move the same distance when it is present without any rotating link. Now you would be thinking that, sir, but this motion is coming because this slider is present on the rotating link. Yes, it is. That's what I am saying. Coriolis component is coming also because of that. And my dear, that is the reason why Coriolis component is giving this extra motion to us. Okay. So this is what is the result of Coriolis component of acceleration. If you will be having only slider, you give that much translation, that much rotation, then slider would be reaching here only. Whether you give translation first, rotation after, or rotation first, translation after. But Coriolis will result into this extra motion. So my dear, this is said to be Coriolis component of acceleration. Now we are left with the direction part. Let us see how to find out the direction of Coriolis component of acceleration. So how this direction part is there. So my dear, if you want to find out the direction, first of all, I would like to tell you, you need to see the sense of rotation of the rotating link. If you see this case, okay, I am making this is the angular velocity. You just need to see whether it is clockwise or anti-clockwise. Just after looking it, you will be saying it is clockwise. So if angular velocity is clockwise, this is the slider velocity component. You need to rotate this sliding velocity component by 90 degree in the sense of rotation. You know, sense of rotation is clockwise. Just imagine a clock, and if you see velocity direction was given like this, according to the watch the time would be 9, and when you are going to rotate it by 90 degree in the clockwise direction, it will be reaching here. So this is going to be the direction of Coriolis component of acceleration. So Coriolis component is always acting on the slider perpendicular to the rotating link, and the direction is given as when you will be rotating the velocity component, the velocity direction by 90 degree in the sense of omega. Never search the sense like niche or upar. Never think like that omega is going downward. No, it is clockwise. So always rotate either in clockwise or anti-clockwise direction. Don't be confused in niche ja raha hai, upar ja raha hai. Always say either clockwise or anti-clockwise. Like in this case, you can see this is anti-clockwise. So this was the velocity direction. So if you just imagine velocity direction is like this. If you go by clockwise the time will be going from 6 to 9, but it is going anti-clockwise. So anti-clockwise means just opposite. So it must come in this direction. So that's why Coriolis is in this direction. So this is how you can find out the direction of Coriolis. In this way, this is the velocity, this is omega clockwise. Just imagine the clock. This is velocity vector. After 90 degree, this will be the time. So this is the Coriolis. So always rotate the velocity vector by 90 degree in the sense of omega. You will find out the direction of Coriolis component of acceleration. I feel you guys are getting it. Let us see the next thing. So my dear, this is a very famous mechanism. I feel everybody would be knowing about this. This is a crank and slotted lever mechanism. As I already told you that these concept capsules are very, very important. These concept capsules are very, very important for interviews. So in interviews, they are asking a question sometime. What kind of question they are asking? They are asking that for how many times in this mechanism Coriolis component becomes equals to 0. कितनी बार Coriolis component of acceleration 0 हो जाता है? So my dear, I would like to tell you that when we have Coriolis component of acceleration as 2 into v into omega. So when v will become 0, Coriolis component will become 0. When omega will become 0, Coriolis component will become equals to 0. And my dear, when you see this mechanism, these are the two situations. When slotted bar is at its extreme. So when slotted bar is at its extreme, because slotted bar is having the motion like this and that. So when slotted bar is at this position or at this position, it is about to change the direction of motion. So when it is about to change the direction of motion at this position, we would be having omega 4 to be 0. Here also we would be having omega 4 to be 0. The link number slotted bar is link number 4. So my dear, when at this position the slotted bar is going to change the direction of motion. So here the velocity will be 0, because whenever some velocity direction is changing, the point where the direction is going to change, their velocity is going to be 0, because when plus 5 will become minus 1, in between it will be reducing to 0 first, and then only it can go to minus 1. So that is the instant when angular velocity is 0. So at these two positions, because you know the slider is sliding on this slotted bar, which is a rotating link. So this slotted bar is rotating about A, and on this link slider is sliding like this and that. So if that is the case, my dear, when slider will be at the position when the slotted bar is about to change its direction of motion and its angular velocity is becoming 0, at these two instants you will be getting Coriolis component as equals to 0. So these are the two places which generally students are knowing. What are the other places? If you see, my dear, this slider, when this crank will be rotating with an angular velocity of omega, definitely this will be the velocity of this point which is present on the slider. But this velocity once again further will be divided into two parts, and it will be having two components. One component will be along this slotted bar, other will be perpendicular to the slotted bar. And this along component is nothing but the slider velocity of slider. And my dear, when this slider would be present at this position and at this position, at these two positions, my dear, when this slider is present at this position, what will happen? The crank will directly give the complete velocity in this direction, and the slider velocity component will become 0 at this position. Similarly, at this position, when crank will be rotating, the complete velocity of the slider will be in this direction for the instant, and there will be no sliding velocity of slider. Why? Because this is the crank, and if it will be having sliding velocity, it has to go by breaking the connection with the crank, which is not possible in a mechanism, because we never allow it to fracture, and if it is going to fracture, it means we need to go for the different mechanism or machine, and that would be considered as failure. So when we are going to make the study, at that time the machine and mechanism are properly working, they are not getting failed. So definitely at these two positions slider velocity would be 0. So my dear, there are two extreme positions. There are two extreme positions of slotted bar and two extremes of slider. So these are the four positions when you will be having Coriolis component to be 0. I am plotting these two conditions. These are the two conditions for slotted bar, and these are two positions for the slider. At these two positions 1, 2, at these two positions 1, 2, we will be having Coriolis component to be 0. So total 4 times Coriolis component is becoming equals to 0 in a crank and slotted lever mechanism. I feel everybody would be getting that. Okay, if you want a specific capsule on some topic, you can comment that, sir, we want on this topic, and whatever previously the topic you have mentioned, we are going to have concept capsule on those topic in the next month. So don't worry about that. Now my dear, I am coming to the last thing, that is a special case, that how the questions will be coming on this. So my dear, when we are talking about the questions, they will be giving you a particular link like this, and they will say this link is rotating with an angular velocity of omega, and they say this is a slider, and the slider velocity is given in this direction v, and they will be asking you what is the net acceleration on slider. So my dear, when we have this type of question, how to see? So my dear, first of all, as you know that because this slider is present on a rotating link, So because of that, at this point there will be a centripetal or radial acceleration will be coming into picture, and this radial acceleration is always acting towards the center of rotation, and its magnitude is given as omega square r. And my dear, you know this omega is given as clockwise. So when this velocity vector, if you see the time, this is the time. If this velocity vector is rotating clockwise by 90 degree, it will be coming in this direction. So this is the Coriolis component of acceleration. And you know Coriolis component is given as 2v omega. And my dear, if you see these both acceleration are at 90 degree to each other, and how two vectors which are at 90 degrees are added up, you know that you will be doing a net as square root of a radial ka square, a Coriolis ka square. This will give you the net acceleration. So this is the second type of question. This type of question you can expect in GATE, and crank and slotted lever you can expect in interviews. Okay. And guys, this is another problem. In this question you can see what is the data in the figure given above. The link 2 rotates at an angular velocity of 2 radian per second. So this is link 2, this is rotating at 2 radian per second. What is the magnitude of Coriolis acceleration experimented by link 4? So this is slider link number 4. You know that when this angle is 90 degree, why 90? Because you can see one thing, this angle is 30 degree, this is 30, so this is 60 degree. So my dear, this is 60, this is 30, this is going to be 90. And I already told you this is the 90 degree, this position, you know that this slotted bar is at its extreme. So for this case, omega 3 is going to be 0. And because of omega is 0, you know that velocity is non-zero, but omega is 0. So because of that, Coriolis component is 2 into v into omega, it is coming out to be 0. So the answer is going to be A. Okay guys, so hope you are getting it. You will be able to see. And these are the concept capsule which are going to help you in the exam. So guys, do watch the sessions, and please tell us if you want a concept capsule on a particular topic. So we will be there to help you. And guys, do like the session, share the session, and subscribe the channel. And those students who want to attend engineering mechanics, we will be having the sessions from today only. You can attend them at 6 PM on the same channel. So like, share, and subscribe. So goodbye for this session. We will meet in the next episode soon with some new topic. Goodbye, signing off for today.